Why robots are taking over agriculture. This new AI Dexterity breakthrough changes everything. The $1,000,000 strawberry. Stop if you think the biggest robotics news is humanoids running, climbing, or jumping. You are missing the real revolution. For decades, the most complex, lucrative, and labor-intensive job on Earth has been safe from robots. Why? Because of, one word, dexterity, that perfect strawberry. A $1,000,000 technical problem. The robot couldn't handle the variability, the softness, the sheer organic chaos of a field. But that time is over. The AI and engineering breakthroughs have finally delivered the precise robotic hands needed to harvest, weed, and prune. And it changes everything. In the next 10 minutes, we're breaking down the AI Dexterity breakthrough that is finally letting robots do the impossible. This is your 10-minute tech update. The problem: why farming is a hard robotics problem. Right, we talked about the $1,000,000 strawberry. But why is it so hard? Think about a car factory. The parts are identical, the lighting is perfect, and the robot does the exact same motion 1,000,000 times. Consistency. That's easy. Now look at a field. Zero consistency. Every plant is slightly different. Every leaf is a different shape. The fruit is hidden, shaded, and growing at its own unique angle. This isn't a factory floor. It's organic chaos. You can't program a single, predictable motion. You need a robot that can adapt, and that is a massive computational problem. Next, the physical hurdle case, the strawberry squish test. Traditional robotics are built for power. A car door weighs 50 pounds. A lettuce head weighs a few ounces and bruises if you look at it. Wrong. A robot has to execute a grab with micro-level force control that can't exceed the crushing point of the produce. We're talking about precision at the milli-Newton level. This is why harvesting has always required human fingers. The fragility is a nightmare for old-school mechanics. And finally, the environment itself is trying to sabotage the robot. Imagine the perfect harvest is happening, and then a cloud passes over. Suddenly the lighting changes, the shadows move, and the robot's vision system goes blind. Plus, we need to talk about identification. How does the robot know if that tiny green sprout is a valuable crop or a yield-killing weed? They look identical to a basic computer. The robot must instantly distinguish between ripe, unripe, leaves, stem, dirt, and shade, all while battling wind, changing light, and maybe even mud. The complexity is insane. That's why we needed a whole new class of AI dexterity, and that is exactly what we're diving into next. Breakthrough 1, the AI vision and sensory system. We established the biggest challenge: organic chaos. A factory robot is dumb. It just repeats a script. The new age robot needed an adaptive brain, and that brain is the AI vision and sensory system. This is the leap that takes us from guessing where a plant is to knowing the ripeness, the health, and the precise geometry of every single piece of produce. This isn't just a GoPro on a tractor. This is sensor fusion in action. Think of it like the robot has superpowers. It combines multiple visual inputs. Normal light tells it the shape. Near-infrared light tells it the sugar content or ripeness. Thermal sensors track the plant's health. The AI instantly stitches all this data together to create a perfect 3D point cloud, a virtual map of the environment. The deep learning model scans this cloud and shouts, "This berry is perfectly ripe, but this one isn't." It solves the identification problem by seeing what the human eye cannot. This is crucial for high-value crops where picking too early or too late costs massive revenue. But just finding the fruit isn't enough. The AI uses this 3D map for precision targeting. The robot has to calculate a dynamic split-second path to the target, navigating around wet leaves, avoiding stems it doesn't want to cut, and zeroing in on the exact sweet spot for the grab. This dynamic pathing capability means the system is no longer reliant on perfect lighting or static conditions. It's making millions of tiny, independent decisions every hour. It's an adaptive, genius brain ready to command the most critical part of the system, the hand. Breakthrough 2. The soft robotics end effectors. The AI brain is incredible. It knows exactly where to grab and how hard to squeeze. But that brain is useless if the hand is a dull piece of steel. This is where the hardware finally caught up to the software. Forget the Terminator claws of the past. These new end effectors are made from flexible polymers and silicone. They are designed for conformity, not force. The robot is no longer trying to grip an item with rigid fingers. It's using air, pressure, a process called pneumatic actuation, to gently wrap its fingers around the fruit, taking its precise shape. This distributes the pressure perfectly, ensuring you don't get the dreaded strawberry squish. This technology is delivering insane levels of microforce control. For smooth produce like apples or peppers, engineers are using advanced suction cups. The AI, informed by the vision system we just discussed, adjusts the vacuum strength in real time, minute by minute, to ensure the lightest possible touch. Whether it's a soft squeeze or a gentle vacuum, this ability to apply force at the millinewton level is the ultimate definition of AI dexterity. It's the final piece of the puzzle that makes the robot takeover of agriculture not only possible, but profitable. Now, let's talk about the economic impact. The global impact, why this matters to you. This technology is not just beautiful engineering, it is an economic imperative. Globally, agriculture is facing a massive, crippling labor shortage. Who is going to pick your food 5 years from now? This robotic dexterity breakthrough solves the problem immediately. Robots don't get tired. They work 24/7. They don't need breaks. They are the only scalable solution. But it goes beyond just labor. This is about sustainability. When a human worker or a standard sprayer attacks a field, there is huge waste. These new AI-driven robots, they embody hyper-efficiency. They can identify a single weed and target it with a microdose of herbicide, or even a laser, eliminating chemical overuse. They only pick the fruit that is perfectly ripe, drastically cutting down on food waste. This AI isn't just picking, it's maximizing yield, profit, and sustainability simultaneously. This is why you need to be paying attention. This AI dexterity breakthrough is creating a multi-billion-dollar market right now. It's unlocking new autonomous systems for vineyards, vertical farms, and massive orchards. The biggest hurdle in robotics, handling the infinite variability of the real world, is being solved on the farm. The future of robotics is not just fast, it's gentle. Now, for the final question, conclusion and call to action. So, there you have it. The AI dexterity breakthrough has closed the gap. The combination of sensor fusion, giving the robot eyes that see the invisible, and soft robotics, giving it the gentle, precise hands it needed, has solved the organic chaos problem. This isn't just about saving labor. This is about optimizing the very source of our food, making farming more efficient, and paving the way for the next generation of truly autonomous systems that can handle the real world. The most important innovation in robotics right now is happening, not in the lab, but in the field. Before you go, let me know, what crop do you think is the absolute hardest for a robot to master? Is it a complex fruit? A delicate herb? Drop your thoughts in the comments below. If you enjoyed this breakdown, smash that like button, subscribe to 10-Minute Tech Update for more, and I'll see you next week.